Hello, and welcome to A Gross of Physics. Today is day 133, and what I'd like to talk about today is the four universal forces in nature. Now, there are four forces that exist in nature, and they are gravitational, electromagnetic, the strong, and the weak nuclear force. And in order of weakest to strongest, it would be gravitation, electromagnetic, weak, then strong. The strong nuclear force is what holds the nucleus together. And what we have is a situation where protons are stuck in the nucleus with some neutrons. And when they're in the nucleus, they are trying to repel each other. But somehow they're stable. And the reason they're stable is because of the strong force. It keeps them together. We're going to discuss binding energy and mass defect in a little more detail tomorrow. But for now, what I want you to remember is that the strong force holds the nucleus together. Now, the weak force is responsible for radioactive decay. Some nuclei aren't held together very strongly. In fact, they break apart and form other elements. That weak force is responsible for radioactivity. In fact, it's also something that's responsible for the fusion reaction in the sun. So some elements can't hold on to their protons, and if you can't hold on to the protons, they break apart and form new materials. But when they break apart, energy is released, and energy is released in the form of radioactivity. The electromagnetic force is it exists with a inverse square relationship. We discussed that in our electricity section. We had KQQ over R squared, which was the electrostatic constant, the charges, and the distance between them. Finally, we have the gravitational force, which we already have calculated a number of times. Newton's law of universal gravitation stated that every two objects in the universe are related to one another and attracted, in the fact that if you take big G, which is 6.67 times 10 to the negative 11, multiply it by the masses of each object and divide by the distance between them squared, you could figure out the force of attraction. Now, although you are listing the gravitational, electromagnetic, weak, and strong force in order of strength, what we are also doing is indirectly listing them in order of their effectiveness. Gravitational forces exist over the entire universe. They can exist no matter where you are in the universe. Electromagnetic don't have a more limited range. The weak nuclear force only exists inside the nucleus, but doesn't have a strong hold on its constituents, which are the protons and neutrons. And finally, the strong nuclear force is only strong in the case of the nucleus itself. So the different forces, although they increase in strength as we go down the list, they also decrease in effective distance that they act. Now, with the strong nuclear force, as I said, that is what's holding the nuclei together. And the way it works is quite odd. If we take each of the protons and neutrons and we put them on a triple beam balance and find their mass, we would get a certain value. But when they're together in the nucleus, that value is actually less than the sum of the parts. And what we call that is the mass defect. And that extra mass that's taken away from each of the particles is actually converted to the energy that keeps it stable. So the fact that we have what we call a mass defect is the energy that binds the nucleus together, which is what we call the binding energy. So at this point, today's a quick lesson. There are four fundamental forces in the universe: gravitation, electromagnetic, weak, and strong. Two exist inside the nucleus and two exist outside the nucleus. And we've already discussed the first two. We've done calculations with them. The second two exist inside the nucleus, and what I want to do is determine what energy values are required to keep a nucleus together. So we're going to look at the strong force in tomorrow's lesson. That's it for today. Very short lesson, but very important in the fact that there are four fundamental forces in all of the universe. And we've already discussed two, and we're about to study the other ones. Thank you. All right, today we discuss the four fundamental forces, and we have the name of the forces, we have the strength, and the distance. And I just want to show the relationship between the forces. The first force is the strong, and that's what held the nucleus together. Remember, we have all these protons that don't like each other. They repel. And the fact that the nucleus is stable at all is due to the strong force. It keeps these repulsive forces from repelling enough to break the nucleus apart. So the strong force, we're just going to use it as a relative strength of 1. It's the strongest. But it only exists within the nucleus. So it's 10 to the negative 15 meters. And that is the size of the nucleus. So it only works in that distance. Now, the electromagnetic force is a little weaker. If the strength of the strong force is 1, it's about 1/137th. But it acts over an infinite distance, which I spelled wrong. Infinite distance. And the infinite distance, although the electromagnetic force acts over big distances, the equation, as we know, is K QQ over R squared. And it affects, as we also discussed earlier, charged particles. Next, we have the weak force. And the weak force is responsible for radioactive decay. Sometimes the nucleus isn't strong enough to hold everything together, and the weak force takes over. It's a millionth as strong as the strong force. And it only acts on a distance of about 10 to the negative 18 meters, which happens to be the size of a proton. And what will happen is the weak force will allow the protons to break apart and form radioactive materials and decay. It releases radioactivity. Finally, we have gravitational, so the gravity force, and that's 1 over 6 times 10 to the 39. Really weak. And that's due to the fact that we have our equation, which is big G, mm over r squared. Same structure as the electromagnetic force, but the G is a much smaller value. It's 10 to the negative 11 in terms of its constant, whereas K was 9 times 10 to the 9. It also acts over an infinite distance, and since gravitational forces involve large objects such as suns and planets and celestial bodies, the forces can become quite large. But we have our 4 fundamental forces in the universe. We have the strong, electromagnetic, weak, and gravity, their relative strengths, and the distances that they act. Electromagnetic and gravity act over any distance we want, although there's an r squared term, so as the distance doubles, it's an indirect square relationship. The strong and weak, the strong is within the nucleus, and the weak is only about the distance of a proton itself. So the protons themselves can actually break apart into smaller particles. Those are the 4 fundamental forces, and everything stems from those.